Hey everyone, myself Danish and welcome to tutorial on Robot Operating System or commonly known as ROS. In this tutorial we'll discuss about ROS, why we use ROS and what are its concepts. So let's start with the introduction. ROS is a set of libraries or tools which are used together by robots researchers and developers to make robot application. ROS officially created and developed by the company Willow Garage starting in 2007. It itself is not a programming language but a software framework for programming robots. Lots of robots like Saviox Relay, SoftBank's Pepper, Willow Garage's PR2, Sports ROS. But it currently runs on a Unix-based system while other variants such as Android, designated experimental and is supported by a ROS community. The next question arises is why we need ROS. So, testing your robot code can be time consuming and error prone, and sometimes physical robot might not be present with you. So working with ROS provides solution to these problems as it breaks the direct control of the hardware and decision making into separate programs. In this way we can replace the hardware part with a simulator and test the behavior of the code. It also provides a simple way to record and play back sensor data and other kind of messages. So because of these features, your software not even knows whether it's talking to a robot or a simulator. It is also an open source software and maintained by a very large community. Note that ROS do not have to be on a same system. You might have Android publishing data and a laptop subscribing them. In order to understand ROS, we have to understand its concepts first. There are three levels of concepts named file system level, computation graph level and community level. In addition to these, ROS also defines two types of names, package resource names and graphical resource name. So let's start with the first ROS file system level. Packages are the main unit for organizing software in ROS. A package may contain ROS runtime processes, a ROS dependent library, data sets, or anything else that is usefully organized together. Packages are the most atomic build item and release item. Then we have meta packages. These are specialized packages which only serve to represent a group of related other packages. The next is package main phase. It provides metadata about a package including its name, version, description, dependencies and other meta info about exported packages. The next we have is message types. It defines data structure for messages. Service types define request and response data structure for services. Then comes computation graph level. It is peer-to-peer network of ROS processes that are processing data together. Nodes are processes that perform computation. A robot control system usually comprises many nodes. For example, one node is receiving data from user and another node is used to compile it and display it. Without the master, nodes would not be able to find each other. What it does is it stores topics and services registration information for ROS nodes. Nodes communicate with the master to report their registration information. As these nodes communicate with the master, they can receive info about other registered nodes and make connection as appropriate. Nodes connect to other nodes directly. Master only provides lookup information. Parameter server allows data to stored by a key in a central location. Messages, nodes communicate with each other by passing messages. Topic is the name that is used to identify the content of a message. A node is interested in a certain kind of data will subscribe to the appropriate topic. Request and reply is done via services which are defined by a pair of message structures, one for the request and one for the reply. Resources that enable separate communities to exchange software and knowledge. The first one are ROS distributors. Collection of version stacks that you can install. They play similar role like Linux distributors. ROS relies on a federated network of code repositories where different institutions can develop and release their own robot software components. The ROS community wiki is the main forum for documentation info about ROS. Mailing list is a channel about main news updates to ROS, as well as it is a question and answer forum. Then we have ROS answers and blogs. Now let's start with name level. First is graph resource names. They provide a hierarchical naming structure that is used for all resources in ROS computation, graphs such as nodes, parameter, topics and services. It is an important mechanism for providing encapsulation. Package resource names, they are used in ROS with file system level concept to simplify the process of referring to files and data types on disk. For example, std_msgs/string, it refers to a string message type in a std_msgs package. These are the references that you can refer for more info about ROS. With this, we have come to the end of this tutorial. Thank you for listening.